Hi, Mark from Jotul. Today I'm going to show you how to take millivolt readings on the SIT 820 millivolt system. The system uses two sources of power. It uses a thermal couple, which powers the pilot coil. It uses a thermopile, which powers the main burner coil. The power from the thermopile gets routed to the valve via these two terminals here, TPTH and TP. They're labeled as such. TP stands for thermopile. First, we're going to take an isolated reading. An isolated reading is a reading in which the thermopile is not doing any work and the circuit is opened. The thermopile is just sitting there in the pilot assembly, happily making power. Because of that, an isolated reading is always going to be higher than a reading under load. A reading under load differs in that the circuit is closed, the coil is being energized, and so you're going to get a lower millivolt reading because your power is being used to create a magnetism to hold the electromagnet open. So we have our multimeter here. It's set to millivolts, DC, and we're going to go to the red is normally positive, white is normally negative, but not always. These can be mislabeled. On this particular system, polarity does not matter. On some systems, if you have a system where you're running a remote control that's powered by a thermopile, or the new SIT pilot on demand system, in order to start the timer, the polarity has to be correct. So the TPTH should be positive and the TP should be negative. And if these are labeled correctly, then red on the bottom and white on the top. You may find that they are not and that they have to be flipped around. So to take a reading, again, isolated, this burner is not energized, or the circuit is opened and not closed. We go to TPTH and TP, and that should give us a millivolt reading of roughly 500 millivolts or better. So you can see we've got 589 and 90 millivolts, or 0.59 volts, however you want to think about it. When we close the circuit, and if this switch here were in the on position, it would allow gas to flow from the valve to the burner orifice, but it is in the pilot position, so that I'm not going to have gas come out of here, yet the coil will still energize. So when we energize the coil, we can see we're not under load now. It's an isolated reading. We've got almost 600 millivolts. We flip the switch to on, and we now have 260 millivolts. My readings are as follows. I like to see 500 millivolts or better for a thermopile that's not doing any work, not under load, and at least 200 millivolts or better for one that is under load, or the burner is on. Again, these are my readings. You may see different readings from different other manufacturers and even from SIT, but these are the readings that I feel comfortable with. From here, I'm going to show you how to take a resistance reading on the coil. In order to take a resistance reading, we have to set our multimeter to ohms, and we have to disconnect the wires from any switches and from the thermopile to the top two terminals, which are TP and TH. These are the actual terminals that allow the circuit to be closed. This TPTH is nothing more than a terminal. It doesn't go anywhere internally. Power needs to be pulled from TPTH and pulled up to TH in order to energize and close the circuit. And that's what the switch is doing, or did when we did it before. So in order to take a resistance reading on the coil, which tells us how much resistance is in that coil, is that coil to specification, we need to set to ohms, and we need to disconnect wires from TP and TH so as not to interfere with our resistance reading. We can now take both a resistance reading and a continuity reading. Continuity just tells us that we have a closed circuit. Resistance tells us whether or not that coil is healthy. So we go to TP and TH, and the spec on this is 2.25 ohms plus or minus 0.5. You can see we've got, so that's 1.75 to 2.75 ohms. Again, some of the other 820 valves are going to have slightly different specs. This is what's worked for me right along. This is typically what you'll see on a healthy valve is somewhere around 2 ohms. A more primitive reading, a reading that doesn't tell us quite as much as a resistance reading, would be a simple continuity reading. Continuity is simply an open circuit or a closed circuit. I know we're going to get a closed circuit here because we have a healthy valve, but just to show you, this is giving us continuity. This is a closed circuit. So we have proper resistance on our valve, we have proper millivoltage going to our valve. If we have any problems here, low burner not coming on, I would suspect that it's going to be something other than either the thermopile or the valve, because this all checks out.